All right, so for the right hand rule, what I do, and it's going to be inverted since I'm doing it on a screen, but you know, let's say so this is my right hand. This would be the positive direction on my side. It probably looks negative on your side. But let's say I have a object that's 3 meters out this way. And so what and the force that points straight up, and so by intuition we know that the force is going to push the object this way in the counterclockwise direction. But the way that we show that through the right hand rule is we point our fingers towards where the point would be, and then we follow the force. Now my thumb is pointing directly behind my right shoulder. I always kind of have my hand out like this over my shoulder, because I know that if my thumb ends up, after I bend my fingers in the direction of the force, if my thumb ends up pointing over my right shoulder, it's going to be clockwise or counterclockwise, I'm sorry. Therefore, it's going to be positive. Now, let's say that we had the force pointing down and it's in the same direction. So I extend my fingers towards the point, and I can't bend my fingers down. So I'd have to flip my hand over. And now when they say it's pointing into the screen or basically what's happening is it's pointing away from your shoulder. That means it's going to be a negative uh, moment, and it's going to go in the clockwise direction. Uh, and for the example for the question for force 2, basically same thing. Here's the wall, here's where point A attaches, and this is the direction that R goes, right? But the force is going back and down this way, which I can't point my fingers that way in this orientation. So I'd have to flip my hand over, my thumb would be pointing away from my shoulder, and then I could bend my fingers in that direction. So therefore, I know from the right hand rule that it is going in the clockwise direction.